Okay, I'm going to go over the energy equations and how to use them, but first, and I do have my equations written out here, I want to go over the units real quick, just to make sure that you're not getting your units confused. Acceleration is meters per second squared. I mean, we could also put velocity equals meters per second if we wanted to, just as a quick review. Okay. Force. The unit for force is kilogram meters per second squared, which is also called a Newton. Momentum is kilogram meters per second, right? It's not squared. Okay. And then energy equals kilogram meters squared over second squared, and that is called a joule. Okay, so you got to watch your units, right? If you end up with a unit that has just the second squared, it's a Newton. If it's neither of them are squared, it's just momentum. There's no special name for it. And in this case, for this section, the unit's going to be kilogram meters second over second squared, which is called a joule. And this is what I'm going to be focusing on the most during this whole thing, is how to work with that. Okay, so let's see here. Okay, so let's work with some of these equations. The first one here is really super simple. It's just a multiplication problem. However, I want to go over what each thing means. Okay, so the first thing I'm going to do, and I saw them doing this in the video, which is actually the correct way of doing it, you have to make a list. Okay, so let's say that I'm trying to find the potential energy of the gravitational potential energy of something. They've given me a problem. Okay, the mass of this system, let's say, is 5 kilograms. Gravity is always going to be the same. Okay, that is a given. Okay, that is 9.8 meters per second squared. It is the acceleration of Earth's gravity. This number is never going to change. Always use the same number. Okay, and let's say the height is, I don't know, 10 meters. Make it easy. Okay, so here we go. All you have to do, again, is take this equation, mgh, okay, and I'm just copying it right here, mgh, right? And all you have to do is take, these are the instructions, like I've said before, take these numbers and put them where the equation says to go. So PE, and that's potential energy. That's not two variables. Yeah, that's okay. This isn't two variables. This is one thing, potential energy. Okay, so mass is 5. Gravity is always the same. And height is 10. Let me get rid of that. Height is 10 meters. Okay. Okay, and at that point, all you do is multiply it through. Okay, so 5 times 9 times 10, 490. Okay, so 490. Okay, here we go, the units, the most important part. Okay, kilogram, there's a meters per second squared and times another meter. So this meter, there's 2 of these meters. So that would be meters squared and then over second squared. So the answer is 490 joules. And that is the answer. Okay, that one's not too bad. Okay, But that's how the units work, okay? And you have to know in order to work with these things correctly that this is what a joule is, okay? Or it's going to be very difficult to get the units right and to keep track of where you are. Okay, so let's do another one. Okay, so this is the mass one. So if I was to take the potential energy equation and rearrange it to solve for mass, it would look like this. Okay, so let's say that the potential energy they give you, these are actually the harder ones. Okay, so yeah, potential energy equals, let's say 3 joules. Okay, gravity is always going to be the same. And let's say the height is 5 meters, keeping the numbers easy. Okay, and then the mass we don't know. So mass equals, now when you write the joules, you're going to want to write the whole unit out. And I'll show you why in a minute. So 3 kilogram meters squared over seconds squared divided by 9.8, right? 5 meters. Okay, or order of operations, right? So we got to do this first. So, and then watch how this works. This is why you have to write the whole unit out. So I'm going to do one order of operations step at a time. Okay, so 9.8 times 5. And if you try to rush through this, you're going to get it wrong. They put answers on there just like any other test. They try to figure out what you might do wrong and put that as an answer. So you have to keep track of what you're doing. So 9.8 times 5, 9.8 meters per second squared times 5 meters. This meters gets squared. Okay, so I've got 49 meters squared over seconds squared. 3 kilogram meters squared seconds squared. The meters squared and the seconds squared cancel out. Leaves me with the only units, which is kilograms. That's what I want, which is a mass. Okay, that keeps track of whether I'm doing it correctly or not. So 3 divided by 49 is 0.06. Good enough. Kilograms. And there's that. Okay, so when you fill in the equation, you're not going to want to put J. You're going to want to put this, the kilogram meter squared over second squared, to keep track of your units like I did here. Okay, so let's do another one. Okay, so this one, another one off the guided notes right there. You can just write it down from here. Height equals potential energy divided by gravity times mass. It's the same kind of problem. Okay, height we don't know. Potential energy I will put in as 20 joules. I'll put these numbers off the top of my head. Gravity we will put it as 9.8 because that's the acceleration of gravity on Earth. And then mass we will put as, I don't know, 30 kilograms. Okay, now you plug it in. So H equals 20 kilogram meters squared over seconds squared. 9.8. And 30. Plug it in. Order of operations, one step at a time. So 9.8 times 30. 294. 294, right, kilogram meters, let's see here, kilogram meters per second squared. Yep. Okay, now watch how this works. This is pretty, you really have to pay attention to your units. So 20 divided by 294 is 0.07. Okay, now the units. The kilograms cancels out. The second squared cancels out. Okay, this is meters squared over meters. So one of the meters cancels out, which leaves me with meters, which is what I want, which is a height. And that's the answer. Okay, it's all about keeping track of your units and doing one order of operations step at a time. Okay, this looks complicated when it's done. Like this looks awful when it's done, but it's because we've gone through all the little tiny steps to get the correct answer. Okay, so another equation they're going to give you is the kinetic energy equation. They write it like this. They go 1/2 mass times velocity squared, which is fine. I mean, it's okay. I'm not super excited about doing that way. Just you can do it either way. You can do it this way if you want. It doesn't really matter to me. I prefer thinking about it like this. I prefer thinking about it like that. Instead of having the fraction there, I am not a huge fan of fractions. So I'm going to get rid of the fraction and do this. I'm just going to take the whole thing and divide it by 2. Okay, so again, and this equation, I'm not going to go through all the different types because I already went over the process of that during the potential energy thing. As long as you do one order of operations step at a time, you will be fine. Okay, so let's say potential energy, I don't know. I'm sorry, kinetic energy, I don't know. Let's say the mass is 10 kilograms. The velocity is 5 meters per second. Okay, and then I just put it in. So mass is 10 kilograms. Velocity is 5 meters per second. And you can see how the units are going to work out here in a second too. I got to take that and square it. Divided by 2. This is an important part. A lot of people forget that, the divide by 2 part. So one order of operations step at a time. You can't be lazy with this stuff. If you want to get it right, you have to do one order of operations step. We're going to get it wrong. Okay, so 10 kilograms, 25 meters squared over seconds squared. And that's where the meter squared second squared comes from. Okay, in this kinetic energy problem. Okay, in the equation, that's where the meters second squared come from. And I got to take that and divide it by 2. So 250 kilogram meter squared over second squared. And then some people will be like, oh, sweet, I'm done. No, you're not done. You still haven't divided it by 2 yet. That's where people, and they will have that as a choice in the multiple choice. They will have this as a choice, 250, because people always forget to divide by 2. So I'll just put this over here. So kinetic energy equals 125 joules. I'll just write joules. It's kilogram meter squared over second squared. Okay, that is probably good enough. Okay, so anyway, with the kinetic energy, they also give you how to solve for each variable, but the process is the same that I showed you before in the potential energy one. It's just one order of operation step at a time. Okay, hope everyone's doing good. Take care, everybody.